Welcome to combinations. Previously, you should have looked over permutations. Now we're going to discuss combinations. First thing we need to maybe look over is this value 0 factorial. What is that value? Your calculator definitely can compute this, but more importantly, you should know it's the answer to this question: how many arrangements are possible when no object exists? There's only one way to arrange nothing, thus giving us 0 factorial equals 1. Now, as we study combinations, again, it's still an arrangement of objects. Okay, so we're still talking about arranging things. It's not a probability, but it is, of course, similar to permutations. Keep in mind now, order is not important. There doesn't need to be a specific order. And objects can only be used once. N still represents the number of objects. R is still representing what we need. And N minus R still represents what we're not using. So ideally, they're the same concept. But why then do we have to divide out by the same number of objects? Meaning, why are we dividing out by this R factorial? Now, as we go through this, we're dividing by that R factorial because there's going to be groupings that are exactly the same, despite who you select. A, B, C, A, C, B. When we're talking about objects not in a specific order, so keep in mind, not in a specific order, these groupings are the same. There's always going to be R factorial ways of having the same amount of groups or the same arrangements. So in this problem here, for combinations, we're dividing out by one extra item. And as a side note, these are some keywords as we're talking about combinations. In this example, we want you to find the number of ways to have a group of 2 from 5 people. Group being the key word in this example. Look, we have 5 choose 2, which is again 5 factorial ways of arranging 5 people, divided by 3 factorial for the people that we're not actually using, and then 2 factorial for the groups that are the same. Because I could take AB and then get BA. Same 2 people, same group. AC, CA. And I continue this process forever. Notice that 2 factorial is 2. There are always 2 of the same groupings. So we have to make sure that we divide out by 2 factorial. How many ways are there to give 3 honorable mention awards to a group of 8 entrants in a contest? Group in this case is not talking about combinations. It's talking about how many people there were total. So we have 8 factorial total entrants. This again is how many people we're not going to receive an honorable mention. So that's 5 factorial. And then 3 factorial again for the number of groups that are going to be the same. As you compute these and solve these problems, the way in which the problem is presented may not be clearly outlined as to a permutation versus a combination. As you become better at these types of problems, you will be able to distinguish them. For example, it says 3 honorable mentions. That implies that there's no difference between one person getting honorable mention and another person getting honorable mention. It's not a specific order. There's no title. In this case, that's what makes it a combination. This problem is a little bit more complex, one in which would be as difficult as we are going to get to during this unit. It says here, Trudy is buying paperback books to read while on vacation? How many different ways are there for Trudy to purchase 3 novels and 2 nonfiction books if there are 10 novels and 6 nonfiction books to choose from? So here we have a bunch of numbers going around, and we need to make sure we understand what's going on. First of all, we need to know how many arrangements or how many ways can we purchase 2 types of books, novels and nonfiction. Now, in this problem here, we're given 3 novels is what we want to purchase and 10 to select from. Hence how we have 10, choose 3. For all the different ways in which we can select those 3 novels. Now when I go to the counter and pay for these books, doesn't matter the order in which I've selected those books, it's still going to be the same 3 novels. That's what makes this a combination problem. Whereas you have 6 total nonfiction books to select from, 2 is what you want, and so we have 6, choose 2. Okay, distinguishing them between each other. We're going to multiply them together because the word and, we want both of them to occur at the same time. So we want nonfiction books and novels, right? And so we need to multiply, as we learned the other day about independent events. What novels you select doesn't affect the nonfiction books you select. This type of problem we will use more in depth with cards. So if you're like an all-star poker fan, a lot of the ways in which we find probability for being dealt certain cards is set up with combinations. Now this closure problem is something that I just want you to consider. What is the difference between a combination problem and a permutation problem? Can you write an example of each type? What are some difficulties that you still have pertaining to each type of problem? If you want to come in and discuss some of these things, please let me know. But this is something that you need to figure out prior to the test. And I will be here to help you. And we'll have some more examples as we go along the way throughout the rest of the unit. But keep in mind, this is always something new, so it may be difficult at first. All right, so hope you guys have a good day.